What's going on, you guys? Mr. Allen here with some geometry and construction, GeoCon, or really any geometry, semester 2 review on quadrilaterals here to start. All right, so we're going through the final review packet here. We have if MNOP, we skipped number 1, by the way, is a parallelogram, find the measure of angle M. All right, so in a parallelogram, we got a lot of information here, right? Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Ooh, okay, that one right there. Consecutive angles are supplementary. That's O and N. So those two should add up to 180 degrees. So I'm going to mark this one with a single arc and this one with a double arc right there, okay? They are not congruent necessarily. They are supplementary. So I can add those two up and set it equal to 180 degrees. So 5x plus 10 plus 9x plus 2 equals 180 degrees. Then I'm going to combine some like terms. So I get 14x plus 12 equals 180. I'm going to subtract that 12 and get 14x equals 168. Then we'll divide by 14 on both sides. And we get x equals 12 right there in the calculator. But that's not my answer, right? It is choice A, but it's not my answer. Look out for that on your final exam, right? Sometimes we give the answer, we ask for an angle, not necessarily solving for x. Sometimes we do ask you to just solve for x. So read carefully, right? It asks for angle M. I don't have any information about angle M, but we did say opposite angles are congruent, so angle M is also going to be the same as angle O, so I have them marked with the same congruent arcs, right? So what I can do then is I can just substitute 12 into angle O right here, so we have 5 times 12 plus 10. 5 times 12 is 60 plus 10, that's going to give me 70 degrees. So our choice here is answer B. Dang. That's dope. And bougie. All right. I don't know why it's bougie, but whatever. All right. Number 3 here. We have trapezoid ABCD, and EF is the median. Find X. So if it's a median, that means it splits those two sides at the midpoint. So like this guy's congruent, or those two guys are congruent. These two are congruent. I don't know if all 4 are congruent because it's not an isosceles trapezoid. It's just a regular trapezoid. But what that also tells me is that my upper base and my lower base, the X and the 47, if I add those two together and divide by 2, take the average of them, it's going to equal that 28. So I'm going to set up x plus 47 divided by 2 equals 28. So how are we going to solve this? Well, I'm going to multiply by 2 on both sides first, and I get x plus 47 equals 56. And then if I subtract 47 on both sides, minus 47, I'm going to get x equals, what would that be, 9? Beautiful. Answer is B. Dope, right? And you can even double check that. You can be like, okay, 9 plus 47. What does that give me? That gives me 56. 56 divided by 2, that is 28. So I could ask you for any one of those 3 sides by giving you 2 of them. Cool? Number 4 here, we once again have a median. We got to find x. This is a little more challenging, but we can use the same idea. So I'm going to set, the light's going to go off here, man. It keeps on going off on me. We got 3x plus 7 plus 6x plus 3 divided by 2. Those are my 2, my upper and lower base. Divided by 2, if I average them, it's going to equal that 22. So a little more of a scary equation here, but we can handle it, bro. We can handle it. All right, we're going to multiply by 2 on both sides, and then those will cancel, leaving me with the 3x plus 7 plus 6x plus 3 equals 44. And then I'm going to combine my like terms on the left-hand side. I've got 9x plus 10 equals 44. Next, I can subtract 10. I'm going to get 9x. 9x equals 34, and then I got to divide by 9. So we are going to get a nice little awful fraction here. Let me move it over here. So we got x equals 34 over 9. Those do not reduce, so I think we're going to leave it as 34 over 9. Wonderful there. That's excellent. Everybody loves an improper fraction. All right, let's move on to number 5 here, man. Number 5, we got a rhombus. All right, important things about a rhombus. All sides are congruent. Diagonals perpendicularly bisect each other. So they split each other in half, and you get right angle here at that angle right there, AED or AEB, whatever you want to call it. That is a right angle, okay? And my diagonals bisect the angles, which is pretty dope too. So there's a whole lot we can do here. But it says the measure of angle AED, which is the one I marked, is 3x plus 9. It says that BC, the side length, is 2x plus 2. Find AB. Interesting. Okay. So first off, we said that we'd have a right angle there. Super important. Jot that down, especially on your colored sheet, right? If you're making your little cheat sheet there, jot that down, that in a rhombus, we have perpendicular diagonals. We can get a right angle. All right. So I'm going to take 3x plus 9. I'm going to set that equal to 90 because a right angle is 90 degrees. And then I'll have 3x equals, if I subtract that, I get 81. If I divide by 3, I'm going to get x equals 27. That's not my answer though, right? Not my answer. I could get BC, so BC is going to be equal to 2 times 27 plus 2, so that's 54 plus 2, all right? And then we're going to have ourselves, what, 56? So that's this side here. But didn't we say that all sides in a rhombus are congruent to each other, right? It's like a square, but it's turned, okay? So 56 is every side. Boom, that's B. Dope. Awesome. All right, number 6 here. We have URST as an isosceles trapezoid. Isosceles trapezoid, the legs are congruent with bases UT and RS. Also, fun fact about a trapezoid or isosceles trapezoid, only one pair of bases are parallel. That's the only one of our quadrilaterals that we deal with where only one of them is parallel. All right. The other ones we got both the opposite sides are parallel, or in a kite, it's kind of like a weird one. Nothing's parallel. But in a trapezoid, one pair of bases are parallel to each other. That's a good test question. Okay, moving on. So UR and TS we know are congruent because the legs are congruent in an isosceles trapezoid. So let's see here. It wants US, or it says US is 3x plus 4. It wants TR. So we don't even have these diagonals drawn in, but we can draw them. Okay. Also in a trapezoid, isosceles trapezoid, our diagonals are congruent. Okay, so that's another piece. But let's go back to our legs being congruent. 2x is going to be equal to 10, right? That's a terrible 0. It almost looks like a 6. So there we go. I'm going to divide by 2 on both sides. Look at x equals 5. And we're going to use this x to now answer the question, okay? So US, I could get US, right? That would be 3 times 5 plus 4. That's not a very good 3. That's better. That's nice. All right, and I'm going to get 15 plus 4, that's 19. So that's US. And didn't we say that the diagonals in an isosceles trapezoid are congruent? Yes, so they're equal in length, so TR must also be 19. There we go. I like it. That's I messed up that R. Sloppy letters. This thing's like vertical. It's a little tough to write on, but I'm dealing with it. All right. Number 7 here. Let's continue. We got ourselves another parallelogram. We have if RSTU is a parallelogram, find the measure of angle S. Well, what do I know about the opposite angles in a parallelogram? They are congruent to each other, so I can set these two equal. So we got 2x minus 60 equals x plus 10. So if I subtract x on both sides and I add 60 on both sides, I'm going to get x on the left and I will get 70 on the right. That's my x value, right? Not my answer. See how it's so tempting? You want to circle A, you're like, I got 70. No, all right? Wants the measure of angle S. We have no information about S, no information about U, which would be congruent to it because they're opposite angles. But we do know that consecutive angles are supplementary. So this angle here, that's going to be 70 plus 10, right? That's 80 degrees, so 80 degrees right here. So what would S be? If I take 180 minus that 80, right, that would give me 100 degrees. So that would be my angle S right there, right? They're supplementary. Angle R plus angle S should add up to 180. So I just subtracted that 80 from it, got 100. Beautiful. Answer is C. All right, now we got a square. All right, square's got like all the properties, right? It's got 4 right angles. The diagonals are congruent. The diagonals are also perpendicular. The diagonals bisect each other. The angles are bisected by those diagonals. It's got everything, okay? It says in square SQUA, what is the measure of angle QAU? Okay, so QAU is this guy right here. Now we said we have 4 right angles, right? So all of these are right angles here. I'll specifically mark that one. We also said that the diagonals bisect those angles. So if I take 90 degrees and I divide it by 2, bisect it, I get 45 degrees. Beautiful. Answer is B. A lot of B's on this one. That's okay though. All right, number 9. We have ABCD is a rhombus, and AC equals 20. And the measure of angle EDC equals 43. Find the perimeter. Okay, in a rhombus, we got a whole lot of information, right? Diagonals are perpendicular bisectors of each other, right? All the sides are congruent. Dope. And That would help us with the perimeter. Let's see what else. We got angle EDC. EDC. So this one right, oops, sorry, not that one there. This one here is 43, okay? And AC is 20. So the whole thing's 20, and we said that it bisects, so this is going to be 10 and 10, right? I want to find the perimeter. If I get one side, and I'm going to mark that as X, if I get one side, then I can just multiply that by 4 and get all the sides, right? So what I'm going to do is I'm going to take this triangle out. We're going to work solely with this triangle right here, okay? And I'm going to jot it down over here off to the side. Yay. Right angle, as we said, the diagonals are perpendicular. That's 10, that's X, and that's 43. If I have an angle and a side, and I want another side of a triangle, what do I have to use? I got to use a little bit of trig, dog. SOHCAHTOA, baby. All right, so across from that 43-degree angle there is my opposite side. Across from the right angle is always my hypotenuse. Get hyped on that, right? The other side, this would be my adjacent, but it's not really important in this particular problem. Since I have my opposite, I want my hypotenuse. Sine, the SO part of SOHCAHTOA is what I'm going to use. So I will have sine of, make a better S here, sine of 43 degrees equals my opposite side, which is 10, over my hypotenuse, which is X. Now I'm going to multiply by X on both sides first. That cancels that one out, right? Then I'll have X times the sine of 43 equals 10. Then I'm going to divide by sine of 43 on both sides. Sine of 43 is just a terrible looking awful decimal, right? That's all it is. So it's a number. So a number times X, I'm going to divide by that number to get X by itself. And now I have X equals 10 divided by sine of 43. And I wrote it like that because that's how we're going to see it in our calculator. Let's bust out that TI and do some work. All right, so I've got 10 divided by, I'll type it all in at once because yo-ro dogs. Let me make sure this calculator is in the right mode. It is in radian. That would have been bad. All right, double check your calculator, right? See how I'm in degree mode once I hit enter? Now we're good. Okay, I'm going to hit second quit to get out of this, but I hit mode to get into that menu. So now I have 10 divided by, and we got sine of 43 degrees. If your calculator ever shuts off, you borrow one from the hub, whatever it is, always check to make sure it's in degrees. So I get 14.662, blah, blah, blah. That's for X. How many sides does this rhombus have? It has 4. So I got to multiply that by 4, and then we get ourselves 58.65. So there's our answer for the perimeter, adding all the sides up. So let's write down 14.66 here. Squiggly equals 14.66 and some change. We multiplied that by 4 and got our perimeter of, what was it, 58 point something. 65. All right, 58.65. And that was in, do we have any? We don't have any units. Okay, that's it. Woo! All right. Next one here. The perimeter of a rhombus is 80 meters. The length of one diagonal is 24 meters. Find the area. Okay, this is a little challenging here. I'm going to draw myself up a rhombus, right? All sides congruent. Now I got a diagonal there, and I have a diagonal there, and I know that they are perpendicular to each other and bisect. All right, so one of these diagonals is 24 meters. That means that it's going to be, what, 12 and 12 meters right there. And the perimeter is 80 meters. If we divide that by 4, I'll get 20 for all of these, right? 20, 20, and 20. Nice. So how do I find the area of a rhombus? There's a couple ways to do it. There's a special formula for it, but we can also just use triangles. All 4 of those triangles are going to be the same. So what is that missing side of the triangle right here? Let's call this X right here. I'm going to draw one of these triangles just off to the side right here. We've got ourselves 12, 20, and X. If I got 2 sides of a right triangle, right, how do I get the third? I'm going to hit it with some Pythag, right? We got ourselves X squared plus 12 squared equals 20 squared. Now, this is actually a 3, 4, 5 triangle in disguise. Okay, 12 would be our 3, and the 20 would be our 5, and we are, what would it be? Multiplying them by 4, right? So if I were to multiply something by 4, like say 4 times 4 would be, and then the other side there would have been 4 times 4, which is 16. So this is going to be 16, but I'll show you guys how to get that with Pythag. Anyways, I think that's a little bit more straightforward on that one. So I'm going to take that 20 squared, and then I'm going to subtract that 12 squared right there. Hit enter, and we get 256. I'm gonna raise that, or actually, we'll go square root. Second square root, and I can just arrow up and grab that 256 right there and hit enter, and I get 16 as we saw, right? So I get x equals 16. So now I got to get the area of this rhombus. We said all 4 of those triangles in there are the same. So if I find the area of one triangle, I can just multiply that by 4. My base and my height of this triangle are 16 and 12. So area of one triangle is going to be 1/2 times 16 times 12. So let's type that in the calculator right there. That'll be nice and easy because we're going to multiply by 4 anyways. So you get 1/2 or 0.5 times 16 times, there we go, 12. Hit enter, we get 96. And then I'm just going to multiply that guy by 4. And we'll get our full area, which is 384. All right, so we get 384 meters squared. Nice. All right, 2 more problems. Dos mas. And Miss Callis got to join here, so she gets to now listen. Isn't that exciting?
I'm very excited.
Very excited to be a part of the production of this video here in the morning at 7:10. All right, the diagonal of a square is 12. What is the area of the square? Oh my goodness, this is insane. All right, so I got a square here with a diagonal of 12. All right, now we could use ourselves some 45, 45, 90 triangles, but I'm gonna clue you in on a little secret. Ready for this dope formula here? Area is going to be 1/2 times 12 times 12. Those would be the 2 diagonals of that square, right? So I'm going to have 1/2 times 144, which equals, what's half of 144? No one's answering. Oh, it's 72. Okay, 72 units squared. Nice. Now, fun fact, you could have used that one up here on the rhombus. Check this out. All right, one of our diagonals was 24, so 0.5 times 24, and the other diagonal was 16 plus 16, which is 32. If we hit enter there, oh my goodness, we got 384. So if you have a quadrilateral with perpendicular diagonals, you can multiply those 2 diagonals together, divide by 2, and you will get the area of that quadrilateral. Kind of a special case formula though, so I don't always use it, but I got it in my back pocket, All right, if the area of a square is 100 square centimeters, what is the perimeter of the square? Nice one to finish off. All right, so the area is 100 square centimeters. Area is equal to what? Side squared, right, for a square? If we call this S and that S, it'd be side squared. So if I take 100 and I square root that bad boy, I'm going to get 10 for each one of those sides, right? So if I want my perimeter, I got to add all the sides or multiply by 4. 10 times 4 is going to give me 40, and that's centimeters. That is a terrible M right there, and that is it for our quadrilaterals here. I hope you guys enjoyed this dope vid. I mean, I enjoyed making it, so hopefully you enjoy it about 20% as much as I enjoyed making it, because that would be that's a win. All right, see you later.